No, sir.
Then how are you doing?
It can do in Moodle app.
Is it?
Yes, sir.
Okay. Okay, I think you have went through these slides. See, so today I try to cover the lettering and dimensioning part. Okay.
Okay.
Okay, sir.
Okay.
Okay,
Did you
sir.
check the layout?
Okay, sir.
So layout that I gave. Okay, so we'll start. So lettering means so in your whatever you are drawing, so we have to give the titles, and sometimes we might have to list out the parts, so the details of the drawing about the material, or add some notes. Notes mean for some any specific. So Oshan, what happened? Any doubts? Oshan, raised your hand. Okay. So in the layout that I have given to you also, you can see several letters are there. So writing the name, details, so such things. Okay. Dimensions, subtitles, so those stuffs. So if you want to show those in your drawings, so you have to know the lettering part. Okay. Lettering means, so in your from your childhood you studied how to write the letters, isn't it? A B C D 1 2 3, so such thing. So how to write those things. So same things we are going to learn here, how to do the lettering in your drawing. Okay. In your drawing, so what are the procedures to be followed for the lettering. So if you take dimensioning also, so you need the lettering techniques. Okay. So you can't use any rulers or the shield you are having for the letters. Okay. So you can find some bar like this, that bar like this, that they are the letters are written A B C D like that. So you can't use those stuffs. Okay. So you have to write freehandly. Freehand mean without using any instruments. Okay. Guiding instruments. Okay. Without using any guiding instruments. Okay. So that is called as freehand. So only with your pencil, right? So if you are writing A, then you have to write it properly. Okay. So properly mean, so you have to maintain the height. Okay. You have to always maintain the height. Okay. So height for each capital letters and small letters having proper heights. Okay. So such you have to maintain. So for the notes, specific notes, you can use capital and small letters. Okay, so normally for other titles, subtitles, dimensioning, so such thing, or material list or such thing, you have to use only capital letters. Okay, only capital letters. Okay, so omit that some of these extra lines are coming because of the technical error in the Zoom. Okay, so network problem. Okay, then so you can't write anything italic. Okay, so you can write for some specific reasons only. So otherwise you have to write vertical letters only, right? So not like italic letter. So italic, you know, okay, that has having a angle. Okay, so without that you have to write it perpendicularly. That means vertical lettering. Okay, A means vertically A, not italic. Okay, so italic also you can use for some notes and special if you want to have some special notations, you can use italic also, right? So lettering in drawing should be capital letters. For your technical drawings, you can use capital letters. Okay, you don't want to need to draw small letters. Okay, so if you studied this capital letters only, enough. Okay, so standard sizes are given. Okay, for your layout, the letter sizes are indicated. Mostly 3 millimeter, 5 millimeter, 7 millimeter, and 10 millimeter, right? That is given for your layout. Okay, layout, that is marked how much the letter height. But if you went to the technical drawing in your sheet, okay, for the tables, subtitles, okay, and for the dimensions, you have to select 3 millimeters. Okay, so main titles you can write in 7 millimeters, right? 7 millimeter letter height. Okay, letter height. So otherwise, if you are selecting 5 millimeters for the subtitles, you have to select 10 millimeter for the main titles. Okay, so in both set you can select either one, right? So that is according to your drawing size. Okay, if it is a big drawing or if it is a complex drawing, you have to put small size. Okay, if it is contains more letter parts. Okay, so there are different notes and some set of indications. So then you can use these small size because you want to add the more lettering part. So otherwise you can put this 5 millimeter and 10 millimeter size. So that is quite bigger. Okay, so if it is if you want to show some only few indications only, then you can put a bigger size because you can cover the space. Okay, and it would be beautiful, right? So here you can see how to write the letters. Okay, so the technique to write the letters are given. Okay, so I normally, some of the people might write like this. Okay, so in engineering drawing this is wrong, and J also you might write like this. Okay, this is also wrong. I mean this only one line. Okay, J mean like this. Okay, these are correct. Okay, so in K you can see K, right? K is a part. Okay, one line. Okay, and then let's say this is your width of your letter. Okay. Then from the center, okay, from the center you have to connect the corner and the center. Okay. And from here, next center and corner, but this should start from here. Okay, that is for the K, right? So that define the width of your size, your letter, right? So then Y you can see here, Y is not like this. Okay, Y is you have to write like this. Okay, and what I am telling is some of the people making problem with these letters only. Other letters are okay, easy to do. Okay, so G is another problem. So G you can't write like this. Okay, this is wrong, and you have to write the G like this. Okay, so you can see here, you can see the technique of G here. So G should come like that. So it should come like and go like this. Okay, so then R also same as K. R also, R normally you are writing like this, but in engineering drawing you have to start from there and write this. Okay, so that is the R. So you can see here how to write the R. And S. Okay, S is quietly difficult, but if you practice that would be okay. Okay, then see the W and M. Okay, W and M are touching the ground. Okay, touching the ground point, not the middle point. Some of the people are writing M and W like this, but M's this vertex should come here and W's vertex should come here, right? So that is the idea. So W not the point on W and M. So other stuffs are okay. So quietly you can follow. And D you can't write like this. So you can't extend these lines. D you have to start there, finish there. Okay. So you can see the D here. Right? And 1 2 3 1 2 3 also like that. Okay, 1 0 6 9 4 7 5 2 3 8. So as I given the this presentation, you can follow that one. Okay, all the techniques are given. So what you have to do is you have to again and again practice these all the stuff. Okay, so in your home you can practice for this letter part, right? So daily you can write the letters with the reference of this given image, right? So in this slide you can follow this slide and you can write them, right? Then we can move to the dimensioning part. Dimensioning part is very important in the engineering drawing, right? So if you when you are drawing any objects, okay, any objects, so those drawing you are making for what purpose? So what do you think about the purpose of making drawings? Anyone? Nobody knows why you are making drawings.
To explore the dimensions and details of the drawings.
Okay, so that is what you are giving with the drawing. But for what is the purpose to draw a drawing? So you are making a drawing, no? You are drawing a engineering drawing of an object or building or electrical circuit or any whatever. Okay. So what is the purpose of making the drawing?
We can easy to understand.
Easy to understand. Okay.
So we can measure how much of the materials we want, and we can
Okay.
Production.
Okay. Any other?
To make the property properly,
To make?
the object properly.
Okay. So actually, what's the reason of preparing this drawing is for the fabrication.
explain-
Production field.
Yeah. It shouldn't be a production field. If you are working on a construction field also, you are having drawing, no? So if you are building a house, you should have a drawing.
To explaining about what we are going to do.
Yeah. So to explain mean, so when you want to explain something, so when you are making something, no?
Or when we are going to make something in construction or electrical,
Yeah.
automobile,
Whatever,
everything.
that's a pre-plan. Okay. So that means you are already deciding this is what you are going to make or fabricate anything. So if it is a small component or something, before fabricating that one, you are making the drawing. Okay. So that means that is the purpose for the fabrication. Okay. So someone is making drawing, and another one is somebody related to the fabrication. He is going to make that component or whatever. Okay. For him to understand, we are making the drawings. Okay. So if we want to make him understandable, then we have to give all the details of the drawing. Okay. All the details mean, so if this component you are going to make, okay, so you have to give all the detail of this component, then he can easily make the drawing. Okay, let's assume that somebody giving the drawing without this pi 54 dimension. So when he is making this component, he don't know what is the idea about this diameter. Okay. So sometimes he can make for pi 50. Sometimes he can make pi 70. Okay. But the size is pi 54. So let's assume if he make with pi 50, okay, that is wrong, no? That is wrong mean. So what happened? This part could failure. Okay. This part could failure. Okay, because of thin feature. Okay. 4 millimeter is reduced, no?
Yes.
As 4 millimeter reduced, so your feature is reduced. So then you might lost your strength. Okay, strength of your part. Sometimes let's assume he made pi 70. So that is strength is increased. But what is the problem? What is the problem there? Pi 70.
Material waste
Yeah,
sometime.
material waste and weight could be go high. Okay, then your what you have expected is not there. So when you are proposing a drawing, so you should make all the dimensions properly. Okay, otherwise a fabricator can't make it properly, then that will lead to other many problems. Okay, so then some designer is designing some part, so someone making that drawing, so you you should propose with the proper dimensions and indications. Okay, so sometimes you might have to give this. Okay, here you can see. Okay, here you can see a small depth is there. Okay, so without mentioning what is the depth, he can't make that, he can't mill that or drill that. Okay, he can't put a drill. What's the depth of the drill, he don't know. And sometimes he might put a long depth drill, or sometimes he might not put a drill that not is that not enough. Okay, then that will lead to the assembling problems, right? So then that is the purpose of making dimensions. Okay, when you are making dimensions, so each and every the components or the details you have to make. Okay, so you can see round and fillets. Okay, so fillets, do you hear about fillets? So when two surfaces are meeting, their fillets comes. Okay, so making that component bit strength. Okay, that fillet will give bit strength to the component. Okay, so rather than having sharp edges, okay, when you are having sharp edges, there is a possibility to break there. Okay, there is a possibility to break on that points. Okay, for that strength, sometimes you might experience with the rubber. Okay, if you are having a rubber like this, okay, let's see, there is a small inside there is a tear. Okay, so then if you stretch this rubber, what will happen? That will easily torn up. Okay, so if you put a round cut like this, okay, if you put a round cut like this, right, if you put a round cut like this one tear. Okay, after this round cut, this rubber won't tear because of this circular section. Okay, because of this circular section, right? So I think it might be hard to understand what I am saying. Okay, so in some practical situations we are using like this. If someone exposed to these problems, they can understand easily. Because so when you are having a round sections, okay, when you are having a round sections, that is easy, that will give a high strength to that part. Okay, so that's why when two surfaces are meeting, that point is made to be a fillet, right? Fillet or round shape, right? Those, because of this written here, I just explained about the fillet, right? So what's our task is, when we are proposing any drawing for a fabrication purpose, okay, we have to give with a very clear idea of that drawing. The dimensions are giving the clear idea about the drawing. Okay, clear idea about this component. And more than this dimension, we might have to give the surface roughness. Okay, what is the surface quality? Okay, those are given as leaders. Okay, given in the leaders. Leaders mean, so as here given, there is a arrow and a note. There is an arrow given and a small note is given, extension line. Okay, so that is called as a leader. Okay, this is dimension, this one is dimension, this one is called as leaders. Okay, if you want to put a special note on this drawing or whatever, you can use leaders. Okay, Otherwise, for the surface quality and building quality and whatever the material to be used, we are using several other indicators. Okay, for the welding quality, we are giving like this. Okay, what is a what's the type of material here, what's the building depth, like that. Okay, if you are giving a surface quality, we are giving like this. Okay, so what is the tolerance have to be made, so such things. Have you heard about the tolerance and fitness? Have you heard?
No, sir.
Oh, okay, then we will study that one in the okay. We will study about that one in the workshop part. Okay, so because we might learn in the workshop, you need that tolerance and other stuff. Okay, clearances not heard.
Sir, can you spelling for the tolerances we will search?
Okay, this is tolerance and clearance. It's better to search. Okay, so when you are assembling or as assembling part, you need these tolerance and clearances. Okay, assembling of components. So when you are making something fabricating, okay, so the amount of tolerance and clearance will be given with your drawing, right? In your drawing there is a hole, then clearance and tolerance will be given. Okay, so you can't go above or below that tolerance rate. Okay, that ratio. Okay, so if you go beyond that point, then that part won't compatible for your future work. Okay, so you got the idea about the dimensioning now. So why you need to put the dimensions? Okay, is it okay?
Yes, sir.
Yes, sir.
Okay, then we will go to how to make the dimensioning. Okay, so earlier we have discussed why we want to make the dimensioning part, right? So why mean, so what's the purpose of having dimension? So if you don't put a single dimension, okay, single dimension, then you will be not you, after this drawing part, some fabricating person who is going to fabricate, he will be in a trouble. Okay, so you should make it clear with the dimensioning. Okay, so that means properly indicate everything. So otherwise there is a, if you sometimes you might miss some dimensions. Okay, so let's assume you are the fabricator. Okay, let's assume you are the fabricator. So you received a drawing and some of the dimensions are missing. Then what will you do? Someone? You are in fabrication field. Okay, so that means you are working in a workshop or something. So there is a part you have to fabricate, or then there you received a drawing that some of the dimensions are missing. In this situation, can you some of you suggest me what you can do?
We have to ask the drawer, designer. Oh, we have to find the correct dimensions.
Ask draftsman to redo it.
No, what are the missing components? We have to ask the drawer, or we have to find the correct dimensions.
How you can find?
Calculation of the dimensions we can calculate.
Calculation. So sometimes if you don't know the calculation,
We need to ask who gave this.
through
Who gave this drawing?
what?
Who gave this drawing?
Who
We ask-
gave this drawing? I thought that was a name. So there's a possibility to find this dimension. What are the dimension? Okay. So most of the time these drawings are made with the scale. Okay. So most of the time these drawings are made to the scale. Or you can find what is the scale of the drawing. Okay, let's assume this is your drawing is given. This length is 120 is given. Okay, they somehow they draw for the scale, no? If that is properly made drawing. Okay, if that is properly drawn drawing. Okay, that means not freehandly with the proper instruments, proper scale, that is drawing. If it is drawing, then this length is 120 is given. Okay, when you are measuring this length, that is 12. Okay, then what is the scale? One is to 10. Okay, 1 is to 10. Okay, then if you don't know what is the dimension of this one, when you are measuring this one, you got the length as 5.4. Then what is the actual length of this one?
54 millimeter.
54. Okay, so if it is properly drawing with the scale, you can find out directly by measuring on the drawing. Okay, if some dimensions are missing. Okay, for the basic dimension, not for the complex dimensions, right? So for these fillets and other things, it's hard to measure, right? These are small curves, no? Those are hard to measure, but those have to be provided, right? Okay, so you can see here there's a dimensioning example has given. So did you studied about this projection symbol? I earlier told you to study about the first angle and third angle projection. As you searched about those things, I think you can find out so a lot of YouTube videos for this first angle and third angle projections, no? So here you can see for this symbol, so this is called as projection symbol. How this made is, this is actually this kind of a part of cone. Okay, a cone that is cut here. Okay, cone is cut here. So you are making drawing of this cone. Okay, now you are seeing from this direction and this direction. This is end view and this one is front view. Okay, So if you draw with the first angle projection, your end view will, your direction is here X and your end view will be here. Okay. Your front view will be here. If you draw for this end view, you will get this as your end view, this small circle and this big circle. Okay. Your front view, you know. For the third angle projection, if the direction X is here, your end view will be here, right? So that means small circle, big circle, and your front view. So this is for your third angle. Okay, third angle projection. This is your symbol. I think in your with your tutorial, I have given the layout design. So in the layout design, all the height and widths are given, no? So you can draw them according to that. Okay, so the projection symbol to the given place, right? So as this is given, so you know this drawing is, so you don't want to write this drawing is drawn with first angle projection. You don't want to write that like that. Okay, so if you just place this symbol there, that is mean that drawing is drawn in first angle projection. Okay, so if it is given this symbol, that drawing is drawn with the third angle projection, right? So if you see this one, certain type of dimensions are given. Okay, R15. Okay, diameter 20, deep 3, C bore. Okay, center bore. So that means, so bore mean that's a hole, right? Hole with a depth. Okay, deep is 3 millimeters, right? Counter bore. C bore mean counter bore. So this is called as leader, right? Here pi 20. So diameter, deep 25. So you can see these indications. Okay, pi, O, D, or you can use DIA, dia. Pi, D, dia. These words are used for diameter. Okay, R, R-A-D, rad. Okay, R-O-R-A-D is used for radius. Okay, so that means radius you know, what is diameter also you know. If the pi is given, then diameter, that is diameter from this point to this point. R mean this point to center. Okay, center to circumference, that distance. Okay, so these indications are for them. Okay, so if it is a small circle, so you can mention the diameter. If it is a big circle, you don't want to draw the whole line and show that what is the diameter. You can just show the what is the radius. Okay, radius you can give from the outside also. Okay, here for the diameter it is given from the outside. Okay, so in this diameter also you can give like there's a line and inside arrow. You can give with the inside arrow also. Also you can give with the outside arrow. That is according to what is your circle size. Okay, if you put a inside arrow, if you think like it will interrupt your drawing, okay, that means if it is not good for show that, then you can give from the outside. Okay, from the outside you can give it. So if you see here, this is given from the inside. From the outside also you can give R something 15. Okay, what you have to think for these arrows on these circles, always the arrow should come outside or go inside to the center. Okay, always this arrow head should come out or go inside to the center. Okay, so if it is a center,
Sir, don't understand, sir.
okay. I don't know what are these lines. Okay, so you are having a if you are having a circle, right? If it is your center, so when you are giving a radius, okay, so this is for radius. Radius you can give in two types, from the center to circumference. Okay, you have to mark the arrow there. Okay, arrow there, that is always from the center to outside this circumference. Okay, if you are marking from outside, okay, like this is your line. This line's head always should be go to the center, right? Did you get the idea? So there you have to place the arrow. Okay, so these arrow heads are always should watch the center. Okay, or for this one arrow head, for this one arrow tail, go to the center, right? Is it okay?
Yes, sir.
Okay, then for the diameter, okay, for the diameter, this is your center, so you know the diameter always go through the center, so you can mark like this and it should go out. Okay, so you can write like pi something here. Okay, it will interrupt your drawing. Okay, so always you have to get the line outside. Okay, straight line, and it should go outside, and you have to break here and write horizontally. Okay, always try to write all the letters horizontally. Okay, so otherwise you can mark, if it is your dimension, the diameter, okay, you can put the dimension like this, put two arrowheads here. Okay, these two, if you should be able to connect these arrowheads. That imaginary line always should
Hello.
go through the center.
හරියන්නේ නැහැ බං මම දැන් පෙන්න එක මගේ සිම් එක ගහලා සිම් එක ගහලා ඩොංගල් එකේ මේ ලොග් කරලා ඉන්නේ.
So someone is talking with mic is turn on, right? Here pi something you can write whatever the pi. This is for the diameter. Is it okay?
Yes, sir.
Okay.
Yes, sir.
Always try to write the lettering part horizontally. Okay. Okay, here you can find out the rules of dimensioning. All dimensional information necessary to describe a component clearly and completely shall be written directly on a drawing. Okay, on the drawing you can write the these dimension. So whatever the information necessary to describe the component. Okay, clearly and completely. Each feature can be dimensioned once only on a drawing. Dimension marked in one view need not be repeated in another view. Okay, so that means, so let's say for this component, okay, for this component you have made this r is 30, okay, radius is 30. Again you don't want to give here 30, always you are given here 30, no, so you don't want to repeat here, right? So if it is a curve here, wherever the curve, you have to give the radius or diameter. Okay, you don't want to give for a straight line. Okay, if you couldn't give a curve line, no, you couldn't mark in a curve line only. You have to use the end view to show those stuffs. Okay, otherwise, if you can make on the curve lines, that there you have to mark the radiuses and diameters. Okay, so if you are given here this height is 35 millimeters, then again you don't want to mark. Okay, once you mark a given view, then you don't want to repeat it. Okay, so another, if you want to show another stuff only, you have to mark it, right? So dimension should be placed on the view where shape is best seen. That is what I earlier said. So here we are marking R30. Okay, radius is 30. When we are marking radius 30, then we should have a curve there. Okay, when we are having curve, you can give the radius. Okay, that is very appropriate. So here your end view, that is straight line, no? That is shown as straight line. If you mark here R30, so people might confuse. Okay, so when this shape is best seen, then there you have to give. Okay,
Yes,
so
sir.
in this detail also, you can mark here 10. Okay, this 10 is given, so it is best to show here also. Okay, so people can easily quickly understand what is the height of this one, right? As far as possible, dimension should expressed in one unit only, preferably in millimeters, without showing the unit symbol. Okay, how many of you have checked the layout? So in the layout, so description page is given. In your description page, so there is a word is given as all dimensions are in millimeters. Okay, all
Yes, sir.
dimensions are in millimeters. So that means you are marking all the dimensions in millimeters. Okay, so if you are going to use in inches, okay, if you are going to mark all the dimension in inches, then you have to change the description as all dimensions are in inches. Okay, sometimes meters, so sometimes kilometers. Okay, so in some bigger drawings, you or some drawings you might have seen this one. There is a scale is given. Have you seen like this? in the
Yes,
bottom
sir.
of the drawing. So then they will mark this 1 meter, 1 meter, 1 meter, like that. So that means if you measure this length on your whatever the drawing, that means that is 1 meter. Okay, so that is why that scale is given. Okay, so those are some key points to understand your drawing. Okay, some of the these micro shape drawing also, the micrometers or nanometer size is given, will be given. Okay, as per the drawn for the scale, right? So then you are marking here. You don't want to write the 40 millimeters, mean you don't want to write 40 millimeters. Okay, you don't want to write 40 millimeters because all the dimensions you already written as all the dimensions are in millimeters. No, then you don't want to give a unit for that one. Okay, already you indicated the unit with the small passage, right? So you can see here you are writing 20 inside. Okay, if you are write this 20 inside, that is disturbing the view. Okay, so this is wrong. So as much as possible you have to write all the dimension outside the view, right? Outside the view. Okay, so and you can only write written in these two directions only. So vertically this direction, horizontally this direction. So you can't write like this. Okay, you can't write 20 like this. Only way you can write is 20. Okay, in this direction, not this direction. This is wrong. So 50 in this direction. Okay, not in that direction. This is wrong, right? So only this direction and this direction, and always outside the view.
Sir,
Right.
can we write the 40?
Yes,
Can you back to?
yes.
Can we write the 40 with 20 plus addition with 20 in the same line?
Yeah, same line
Yeah.
you can also give. From here
Yeah.
you can give 20 and 20. Okay, so you shouldn't write the part. Okay, you don't need to write the
Yes.
Okay, because unit
All.
symbol already you have written there, so you don't want to write it. So if
Okay.
you start to write all the and km and everything, then that will mess up. No, your drawing will be not beautiful. Okay,
Yes, sir.
yeah. So here you can see your doubt, right?
Yes.
So part by part you can write. Okay, so there are some techniques for writing these parts. Okay, we will discuss that one. Okay, so for the hidden line, it's better to omit write the dimension for the hidden lines. Okay, so you can see these dimensions are written for these hidden lines. Okay, so for visible outlines, it is better to draw the dimensions. So we will study a part that is sectioning of solids. Okay, sectional views. Okay, sectional views means sectioning this solids, and that is imaginary section. Okay, section mean cut. Okay, if you want to see what is inside of your cake, okay, so you got a cake that is made of chocolate lava cake. If you want to see the chocolate lava one, you can cut it and see it, otherwise you can't see. Okay, am I correct? So those purposes we are make cuts. So like this in components also, if you want to see inside details, we are cutting it, but not cutting that is a imaginary cut. Okay, with our imagination we are cutting that component. Okay, see what is inside of that, or show what is inside of that. Okay, for those we are using this sectional views. Okay, these are called as sectional views. So in the sectional views only visible lines will be made. Okay, no any hidden lines. No any hidden lines. So when you are showing any hidden details, so you shouldn't use a normal view. You should use a sectional view to show your dimensions. Okay. So here also you can see this dimension guideline is not going inside. Okay, not going inside. That is stop on this surface. Okay, stop on this surface. So no gap should be left between feature and the start of the extension line. So this is called as the extension line. This line is extension line. No gap here. Okay, this extension line should touch the surface. Okay, these extension lines and these dimension lines are made with H pencil. So that is very thin and light lines. Okay. Okay, crossing of center line should be done by a long dash and not a short dash. Okay, crossing of center lines mean so if you have a circle, you are having center lines. So in manual drawings, we are making as these centers, making of centers made by these long dashes, not the short dashes. Okay, but when we are going to the computer aided designs and drawings, we don't want to worry about these such small things. Okay, so that is automatically everything will be fine, right? But for the manual drawing, you have to consider these stuffs. So narrow spacings. Okay, narrow spacing mean if it is a very big part and small gap or groove is there. Okay, there is a narrow gap is there. So if you want to show this gap, sometimes you can't write letter inside of that space. Okay, sometimes you can. If you can, then you can use like this. Okay, arrowhead is from outside and inside. If you can, then you can use this one. Otherwise, if you can't show such a thing, then you have to write outside of this gap. Okay, outside of the gap, you have to write from the outside arrow. Okay, so this also you can show. This part and this part are 10 millimeters. Okay, so here you can use this arrowhead. Okay, for the architectural drawings we are using this. So architectural drawing mean those who are going to construction field, you will get the architectural drawings. So most of the architectural drawings, they might use this arrowhead. But if you come for this automobile technology and these mechanical components, most probably you will get normal arrow. Okay, normal arrows, right? So this is for the vertical. This is for the horizontal. Okay, lead a line as I earlier said. So to make some small notes about your stuffs. Okay, a leader line is referring to a feature, object, outline, dimensions, or such thing. Okay, special note. Leader line should be inclined to the horizontal at an angle greater than 30 degree. Okay, for the horizontal, this should be more than 30 degree. More than 30 degree, right? Not less than 30 degree. So leader that should terminate with a dot. Okay, so you can use a dot or arrow, or for these gaps you can use without any dot or arrow or whatever. Okay, so you can directly put on the dimension. So that means if you can't write anything here, okay, not space is not enough, then you can put a leader and write what is the length of that one. Okay, so here this is a round feature, so you can put a leader and show that this is R50 or whatever. Okay, so such thing. Termination of dimension line. So you are having several terminations. So okay, so this round, this slash, or this type. Okay, this is the normal type that we are in our manual drawing. We are going to use this one. Okay, these things you might have used in your civil drawings and architectural drawings. You might use. Okay, so this arrowhead, this is called as the depth. Okay, depth of the arrowhead, and this is length. Okay, most of the time this length is 3 millimeter and depth is 1 millimeter. Okay, when you are drawing a arrowhead, this is 1 millimeter and 3 millimeter, and you have to fill it. Okay, this is called as closed fill type. Okay, closed fill type. So this one, this length is 3 millimeter, this depth is 1 millimeter. Okay, you should consider these stuffs when you are drawing an arrowhead. Okay, so if you are drawing an arrowhead like this is wrong. Okay, you should fill, and this is not the proper length. This is not the proper length. This is like 1 millimeter and 3 millimeter. This is wrong. This is 1 millimeter and this one is 3 millimeter. So if you draw it incorrectly and if you didn't fill it, that also wrong. Okay, if you draw like this one also wrong. So you should be care about this one. Angular dimensioning. Angular dimensioning. So you should use a compass. Okay, you should use a compass to draw the angular dimension line, and you should make the arrowhead go to ends, and above the line you have to write your letter. Okay, so letter should be 3 millimeters. Okay, always you have to write letters above the dimension line. Okay, above the dimension or leader line with 1 millimeter gap. Okay, with 1 millimeter gap. So this is your dimension line with the 1 millimeter gap. You should write your letter, whatever the dimension of that one. Okay, there should be a 1 millimeter gap. Okay, this is your dimension line. Okay, so here you will get your arrowheads, right? So your letter size will be 3 millimeters. Wait a minute. Okay. When a radius is dimension only arrowhead, so this radius stuff I already discussed with you. Okay, so in these shapes, okay, so you can see some of the shapes here. So you can see only the 2D images here, no? So you don't know what is the actually stuff, okay, with the drawing only. But with the dimension, I can imagine what is the actually what is given here. Okay, with the I can imagine 3-dimensionally. Okay, so first of all, we will discuss this one. So if we see this one, so you can see pi 40 and pi 30. Okay, pi 40 and pi 30 is given. So this is not a line, that is a circular cross section. Okay, circular shaft, right? This is a circular shaft. So it's like this. Okay, so by seeing this dimension, you have to imagine what is the stuff. Okay, so this here you can see this is a R15 and this is R10. So that is more circles are there. So here you can see this one. So here this shape is given, cross shape. If it is a cross shape, that is rectangular cross section. Okay, rectangular cross section mean like this. If it is a cross shape is given. Okay, so that's why this cross is made. And then you can see here there's a square and 40. Okay, square and 40 mean that is not a rectangular, that is actually a square. One side is 40. Okay, square cross section and one side is 40, right? So if you see here SR 60, SR 30. Okay, SR mean R, you know, radius. SR means sphere radius. Sphere radius mean that is a sphere, part of a sphere. Okay, here also you can see S pi 50. S pi 50 means sphere diameter. Okay, sphere diameter. So this is not a circle, this is actually a sphere. Okay, this is like a dome. This is also a dome, right? So arrangement of the dimensions, okay, this is called as chain dimensioning. So as Dinesh asked, so chain, continuously put the spacing between the spaces. Okay, so 160, 30, 85 and 63, 83, 43, like that. Okay, this is called as chain dimensioning. This is called as parallel dimensioning. That means using parallel lines. Okay, using parallel lines and having a reference line. Okay, this is the reference point and marking this one. From here marking this one. Here marking this one. Okay, but in the chain dimensioning, the reference point is always changing. Earlier this was the reference point. From this reference point to this reference point, 160. And then this after this is the reference point. For this reference point to this reference point, 30. This reference point to this reference point, 85. Like that. Okay, reference point is changing. But here, fixed reference point. Okay, this is called as combined dimensioning. That means using parallel and chain. Okay, here you can see parallel dimensioning also there and chain dimensioning also there. Okay, so that is called as combined dimensioning. So this total length also shown, and from the reference points dimensions are also given. Okay, this is about the dimensioning, right? So do you have any doubts? Do you have any doubts in dimensioning?
No, sir.
Okay, is it clear?
Yes, sir.
Okay,
Yes, sir.
I think it's actually difficult for everyone to understand from these lectures, because peer-to-peer meeting is different, and this one is I can come to everyone and ask questions. So if anyone having doubts, you can ask me. I'll try to clear that one. And you should go through with these questions I have given. Okay, so from those type you might get 2 or 3 questions for the mid semester exam, right? So same question will not repeat, but same kind, right? So all the reference stuffs are there in the internet. Okay, so draw the conic section, how you can make the conic section and other stuff. So
Sir, when we draw a drawing, we want to use HB pencil.
which one?
When we draw a drawing,
Yes.
we have to use HP pencil. Am I correct?
So that is according to whatever the
Purpose.
light, the whatever the line type you are using. Line type means, so for a visible outline, you should use B pencil, right? For a center line, you can use HB pencil or H pen.
Okay. Okay.
So if it is a thin
Then
line,
our
thin line or thick line, that is depend on. If you want to mark thick lines, then you should use HB pencil or B pencil. So HB pencil you can use as much slightly dark and slightly light. Okay, so that is under your hand control.
okay, sir. Okay.
Yeah,
Thank
but
you.
I can use B pencil as a H pencil also. By giving the proper pressure, I can control with that. But if I go beyond the B pencil, that means HP pencil, then if I give small pressure also, that will make a big difference. Okay, so that's why you should have H pencil and HP pencil and B pencil with you. Okay, so all the thin lines you should make with the H pencil, because when the pressure changes also, that won't give a that much of dark lines, right?
Okay.
Yeah, but we will in coming sessions we will learn freehand sketching. Okay, when you are coming here, I think that's the better, because freehand sketchings are quite difficult to understand from a Zoom lectures. When we are learning the freehand sketching, all the lines you should make with the B pencil. Okay, in that freehand sketching there we will study about the hand pressure, how we can control the hand pressures. Okay, what else? I think only Dinesh and Uma Shankar is asking some questions. What others doing? So go through with the tutorial. I think no one is done fully, no?
Yes, sir.
Yeah, you should do that tutorial properly, because all the questions asked in the tutorial, most of the stuffs are in internet. Okay, so internet means the studying stuff you can get, the idea you can get, and then for the questions you should have your own involvement. Okay, to draw it.
Excuse sir,
Yes,
the tutorial we can submit.
the tutorial
That-
you don't want to submit, but you have to done that one. When you are returning here, I will check.
Okay, sir. Thank you.
Yeah. That means don't wait for until coming here. You have
Okay,
to
sir.
do by now, but in coming next week or this week, I will put another tutorial.
Okay, sir.
Yeah.
So can you put the recording of these lectures in Moodle app?
Okay, I'll put. I am recording now. I'll put it. Any doubts?
Sir,
Yes.
if you give the that internet link or anything to us. It is very helpful to fulfill the
Yeah,
tutorial.
I know, but then you won't have any search, no. You should search, no. So if you
Sir, I
yeah
already searched, but there are a lot of things. I
yeah
don't know what is for helpful us.
yeah, there are a lot of stuff. Whatever you can learn.
So for some of the questions, we are unable to find the accurate answers in the tutorial.
Which one?
That drawing a square inside of the triangle, that question.
That
I
one.
do have the same doubt. Yes, sir.
Okay, for that one I'll put a note.
Yeah, sir. We saw many videos, but it's difficult to understand, sir. That's it.
Right, for that one I'll put a reference.
Okay, thank you.
Any other stuff? If you don't have any doubts, then we can end this session. Seventy people are here. Where are others? I think your group is 99 or 100.
96, sir.
96. When this one reduced? Is it from earlier? This is 96.
So I think 99.
99, sir. And we have another batch miss person also. We are totally 100. Four people didn't register.
Is it? They left.
Yes, they didn't register. And newly we get 3 more persons from the waiting list, but they didn't register yet. For
Is
university.
it?
Yeah.
Let's see. So somehow more than 90 is there and 71 participants are here. So this time we don't have this other room problem, no?
Yes, but today is not.